So far, up until this point, we've always studied square roots, and we'd say that the square root of a positive number, such as 25, is equal to both positive and negative 5. Now, recently we took a look at the square root of negative numbers, and we recognized their solutions are imaginary. So today we're going to extend the study of square roots into this thing called an nth root. Now, a number b is an nth root of some number x if and only if you can take b and raise it back to that same power to get x. So in our example here of 25, we'd say both positive and negative 5 are the square roots of 25, because if I take positive and negative 5 and square it back, I'll end up with 25. All right, now from that extension, we have this 1 over n exponent theorem. And it simply says that x to the 1 over n is also known as the nth root. So because I took the square root of 25, I could say that 25 to the 1/2 power is the same thing as the square root of 25, which results in both positive and negative 5. All right, let's extend that to this idea of cube root. We could say that the 2 is the cube root of 8. So 8 to the 1/3 power is equal to 2. In other words, this 1/3, this exponent of 1/3 represents the cube root. All right, now from this, we have this number of real roots theorem. And this just tells us the number of real roots we can derive when we're taking a square root or a cube root or a fourth root or a fifth root of either a positive or negative number. All right, now when we're dealing with positive real numbers, we recognize that there are two real roots when n is even. This is our example of the square root of 25. 25 was positive, and the root that we are taking was the square root, which is 2, and that's an even number. So there's two real solutions. When we have a positive real number, we recognize that there is one real root when n is odd. Now this would be our example of the cube root of 8. Our only solution here is positive 2. Now, when we have a negative real number, we know that there are 0 real roots when n is even. So this would be like the square root of negative 25. There are no real solutions, but there are two imaginary solutions. All right, if there's a negative real number, we know that there will be one real root when n is odd. So this would be the example of the cube root of negative 8. What can I multiply by itself 3 times to equal negative 8? And that solution would be negative 2, because negative 2 cubed gives me back negative 8. All right, now 0 will always have one real nth root. Now let's get into some examples and hopefully help you solidify some of these new theorems that we're learning. It says to evaluate here, 27 to the 1/3. So this represents the cube root of 27. Or in other words, what do you multiply by itself 3 times in order to get 27? And that solution is 3. Because, like I just said, if I were to take 3 and cube it, then I would get 27. All right, now let's take a look at negative 27 to the 1/3. And just note the difference between A and B. Now in A, we had an odd root. Likewise, in B, we have an odd root. However, we had a positive number here in A, and we have a negative number here in in B. So our solution here in B is going to be negative 3, because if I take negative 3 and raise it to the 3rd power, that's negative 3 times negative 3 times negative 3, which results in negative 27. All right, our letter C example says 25 to the 1/2, which is the square root of 25. In other words, our number here is positive and our root is even. So I should have two real solutions, and that's both positive and negative 5. In letter E, I have the same situation. I have a positive base, and my root here is even number because it's 4. So I want the 4th root of 81. So I'm looking for the number that I multiply by itself 4 times in order to get positive 81. And remember, there should be two solutions here. In fact, the two solutions are positive and negative 3, because if I took positive 3 and raised it to the 4th, I would get the same thing if I took negative 3 and raised it to the 4th, and that would give me 81. All right, our last example here in this one says the 1/3 exponent of 1000 over 27, which remember I need to make sure both the numerator and the denominator get that exponent, and that exponent represents the cube root. So the cube root of 1000 is 10, and the cube root of 27 is 3. So 10/3 is what that one reduces to. All right, example 2 now wants us to find all real solutions of the following equations. So when I see I have x cubed equals negative 343, I recognize that my power here is odd and my result here is negative. So I'm looking for a negative number here. Well, to undo this cube, I'm going to take the cube root, or in other words, the 1/3 power. And again, the rules of algebra apply. What I do to one side, I have to do to the other side. So I have to take the cube root of negative 343, and this will give me x, because 3 times a third is 1. X is going to now be equal to negative 7, because negative 7 cubed would result in negative 343. All right, in letter B here, I have x to the 5th plus 9. I'm going to subtract my 9 over, and that's going to be equal to negative 3 now. And now I want to find out what I'm going to raise to the 5th power to equal negative 3. Well, in order to undo this, I need to multiply both of my sides of my equation by this 1/5 power. So I'm going to take a 5th power of both sides, which means I'm going to take the 5th root of negative 3. Now, x to the 5th to the 1/5 just represents x. And now I'm going to go to my calculator and show how you guys can do this on your graphing calculator. All right, so in your graphing calculator, you can enter in your negative 3, close your parentheses, and you're going to raise this to the 1/5 power. And so we're going to use a little up arrow, and now we're going to just do 1 divided by 5. And we'll press enter, and this will give us our solution of negative 1.24. So x represents negative 1.24. All right, let's try solving for variables here in example 3. Again, I'm going to isolate my variable, so I have c to the 1/8. I am going to take this positive 27 and move it over to the other side by subtraction, so I have 3 now on the right-hand side. And I want to get c by itself. So this is the 8th root of c. And now in order to undo the 8th root, oops, that's c to the 1/8, I'm going to raise it to the 8th power, which means I need to take 3 and raise it to the 8th power as well. This 8th root and 8th power undo each other, and I'm left with just c to the 1st power, and 3 to the 8 is 6,561. All right, in example B here, we're going to get r by first of all isolating it. So I'm going to add over my 5, and I'm left with 2r to the 1/3 power is equal to 11. Now that 1/3 is only on the r, so I now need to divide both sides by 2. So I'm left with r to the 1/3, or in other words, the cube root of r should be equal to 11 halves. Well, to undo that cube root, I'm going to take the cube of both sides. And when I do that, I'm going to have just r on the left side, and 11 cubed over 2 cubed, and that simplifies to 1,331 over 8. All right, now a little bit further down in your notes, it says real roots can also be found by graphing systems. Recall that the solution to a system is simply the intersection point of that system. So, for example, to find the solution of x to the 4th, we can graph this system y equals 4, which is our blue horizontal line here, and y equals x to the 4th, which is our orange equation here, graphed equation. So their intersection points, as you can see here, are at 1.41, 4, and the other one is going to be the reflection over the y-axis, which will change the sign on our x-coordinate, negative 1.41, 4. So our two solutions to this system here are our two intersection points, and that's 1.41 and negative 1.41. All right, next we want to find the solution to x cubed equals 8, and we're going to graph the solution y equals 8, which is our horizontal line through 8. Here's y equals 8. And our graph of the cubic equation, which passes through the origin, 1 over 1 up, negative 1 over and 1 down, and then 2 over and 8 up. All right, and then 2 over down. So this is what our graph is going to look like, something like this. And we see that point of intersection is at 2 over and 8 up. So there's only one solution to this, and that should make sense because we have an odd power, a positive number, and that solution should be positive. So we say that 2, 8 is the solution to this system, and it is the solution to that system. All right, so that wraps up your notes for today, and we'll see you in class.